All right, let's talk about the derivative of the natural logarithm. Now, this is only for the natural logarithm, whereas we discussed logarithms in general when we reviewed the logarithm rules from algebra. This one does not apply to logs. We're going to talk about them separately. So just like we talked about e to the x, just e to the x, this is the corresponding logarithm. This is the log that has base e. So first of all, if you have just ln of x and you want to take the derivative, the answer is 1 over x. Now, there is a condition that the x value has to be positive. That's because ln is only defined when the x values are positive. All right, now, we're not just interested in ln of an x by itself, we're also interested in ln of a function. So let's talk about what happens in that case. So the derivative of ln of a function, you need to use the chain rule. So we've just written out the chain rule here for you. So remember, the chain rule says you take the derivative of the outside first. Well, in this case, the outside is the ln. So when you take the derivative of ln, remember that was 1 over the x? Well, in this case, it's 1 over the inside. The inside stays the same. Notice it's 1 over whatever you started with. But then you multiply by, chain rule says, the derivative of the inside. So we have one new rule. The derivative of ln is 1 over the inside. And then if it's got a function inside, you multiply by the derivative of the inside. Let's try an example. So here we're asked to find d dx of ln of x to the third. So we have a couple options when we approach this problem. We can do it as is, or we can consider if any log rules could simplify the work for us. I'm going to do it both ways with you. First, let's start with the way it is. So we have ln of x to the third. This is not just the ln of x case. This is the ln of u. So let's mark our inside. That's the x to the third. And let's mark the outside. In other words, I'm saying we need to use the chain rule here. So the chain rule says we do the derivative of the outside. Well, the derivative of ln is 1 over whatever was inside, x cubed. But you're not done. You still need to multiply times the derivative of the inside. The derivative of our x cubed is 3x squared. Are you done? Not in this case. Look what you can do. You have x's on top and bottom, so you can reduce. Cancel x squared from the top, cancel x squared from the bottom. So on top, you're only left with a 3, and on the bottom, an x. And there you go. Now, I want to do the same problem again, but I want to stop and ask myself if algebra could make this problem easier for us. So I want you to look at this. If you have your log rules written in front of you, I want you to look at your log rules. Any log rule that we talked about, are there any log rules that we talked about that we could be used here? We don't have a product unless you want to write x times x times x. That's more than you need to do. We don't have a quotient, but we do have a power. What does the log rule say we can do with a power? This is not the derivative rule. This is the algebra rule. Algebra says we can take that 3 and put it in front. So let me mark. This is just algebra. I'm not taking the derivative yet. So when I write this, I still have to leave my d dx because I still need to do the derivative. But now I'm going to do it on 3 times ln of just an x. Remember, the 3 is a constant multiple, so we can bring out of the derivative. So really, we're just doing 3 times the derivative of ln of x. Oops. I don't need the absolute value. What am I doing? There we go. Now, ln of x has its own derivative rule. It's just 1 over the inside, and that's it. Why is that it? Because then you multiply it by the derivative of x, which is just 1. So the chain rule doesn't add any information. So the 3 chills out. The derivative of ln of x is 1 over x, and put them together. You get exactly the same thing you got the other way. Now, technically, you could have shortened this a little bit, but I wanted to show you all the steps. So hopefully, that's a good example for you. Let's try another one here. Derivative of ln of x squared minus 5. Okay, well, if we do it straight up the way it's written, this is the derivative of 2 functions inside of each other. So we need the chain rule. We have our inside, and we have our outside. The derivative using chain rule says you do what first? The derivative of the outside. ln says the derivative is 1 over the inside. The inside stays the same. Then you have to finish the chain rule. The derivative of the inside is 2x. So put them on top of each other, and you're done. Now, technically, this problem could also be approached in a different way. We could factor the inside, but this is not nicely factorable. We would end up with square root of 5, so I would not go that route for that reason. But if it's factorable, you could factor it and use the product rule to break it up if you would like to. But this is actually the best way in this case, unless you really like square roots. Let's try another derivative rule. So this is not ln anymore. This is similar to our e to the x rule. Remember, we already talked about the derivative of the base being a number e, specifically that number only, to the x, specifically that power only. And we said that the derivative of this was just itself. Well, how does that change if instead of e, we put an a? Is it going to be the same rule? As a matter of fact, not quite. You have to multiply by ln of that base. If this had been e, this would be ln of e, which is just 1. But because we're changing the base now, we have to multiply by this extra term. Now, in the box here, we actually have the derivative in terms of the chain rule. So the chain rule says you take the derivative of the outside. When you have an exponential like this, a number to a function of x in the top, you keep it the same. You multiply by ln of that base, and that's the derivative of the a part. But then you need the derivative of the exponent because of chain rule, and that's what this part is here. Okay, there are a couple conditions. Your number in the base has to be positive. Requirement. So if I had negative 5 to the x, this we cannot do. Negative 5 to the x, we cannot take the derivative of using this rule. U has to be differentiable. If you can't take the derivative, then you can't do the du dx. As long as a is positive and u is a function you can take the derivative of, then a to the u is a differentiable function, and this is the formula. So let me show you an example. Derivative of 3 to the x. So notice it's a number that's not e. If it were e, we go back to the old rule that we had, but this is 3. Well, the rule says we keep the same thing, 3 to the x, times ln of that base. The base is the 3. Then times the derivative of the inside, but in this case, that's x. So this is actually the shorter version at the top that I wrote. So you just write 3 to the x times ln of 3, and that's your derivative. So keep it the same, ln of the base, and then if the function is something interesting, other than x, multiply by the derivative of the inside. Let's try another one. So again, we have a number base. So this is an exponential with x in the power. So the rule is you keep it the same times ln of that base times, we're not done because we still need the derivative of the inside. What's the derivative of the inside here? 2x. Now if you want to rewrite that can, but really none of these can combine together. Do not put the 2 and the 3 together. That's not allowed. They have different exponents. The last rule that we need to talk about in this section, derivative rule, is the derivative rule for logarithm. So remember, we already talked about the derivative of ln of a function. And we said that was 1 over the inside times the derivative of the inside. I want you to look at this one. What's different here? By changing it to log base a, meaning we're not base e. Remember, ln is base e. You don't have to write it. By changing our problem to log base a, what changes in our formula? We still have the 1 over u. We still have the du dx. But just like the a to the x rule, we have to involve the base in our derivative. So you're going to have ln of your base in the denominator. So let's give it a try in this example here. Now this is 2 separate terms, so we take the derivative of each separately. So the derivative of log base 2 of x. It says it's 1 over the inside, which I like to write these separately. You don't have to, but I do. 1 over ln of the base. Remember, this little 2 down here is your base. times the derivative of the inside, which in this case, it's just x inside, so the derivative is just 1. So those are the three pieces when you're taking log base anything other than the ln case. Plus, let's do the second term. The derivative of log is 1 over the inside, stays the same, times, because it's a different base than e, we need ln of that base in the denominator, times, we're not done, that's just the log derivative, now we need the derivative of the inside. Well, the inside's just x cubed, so that's 3x squared. Let's clean it up. So 1 over x ln of 2, if we put all that together, plus, in the second one, we have x's in the top and the bottom, so we can reduce here. So we end up with a 3 on top and an x ln of 2 on the bottom. And there you have it. If you wanted, actually, not if you wanted, we actually look at this, we're not done. I just realized, look at the denominators. Both denominators are the same. The numerators don't involve an x, so these are actually like terms. We can add them together. So keep your common denominator, add the tops together, and now we're done. So those were all the derivative rules for logarithm, so ln, log of any base, base a, and then also the exponential, a to the x power, or a to the u power, if it's a function in the power. We're going to do one more video with examples of all these, but for this video, those are all the rules, and now go give it a try, practice, but there's another video with some examples. So I'll see you in the next one.